let's take a look at the agenda for this session. So first of all, I will start with the prerequisites that are Python functions, and then I will talk about Python decorators with a few examples. And finally, I will discuss a rather complex concept that is fancy decorators with a few examples as well. I hope you guys are clear with the agenda. Also, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates from Edureka. So without wasting any more time, let's start our session. I'm sure most of you are familiar with functions in Python. So let's recall some of the important concepts that are going to be useful while working with the decorators. So the concepts that I want to discuss are first class objects and inner functions. So in Python, literally everything is treated as an object, including all the data types and even functions. So the functions can be passed around as arguments as well. So that is why it is called a first class object. Coming on to the inner functions, a function can be also declared in another function which is known as an inner function. It also resonates around the decorator, so we'll get to that later on in the session. So let's take it up to PyCharm and understand how inner functions work, and we will also try to return a function from a function, which is actually passing a function as an argument. So let's take it up to PyCharm, guys. So now that we are in the PyCharm, let me go to the presentation mode so that the clarity will be better. So first of all, let me talk about the first class object. So I'll just take a function, name it as, let's say, function1, and inside this I'm going to pass a variable name. So now I just want to return, let's say, hello. So for this I'm going to use the string interpolation. If you're not sure about that, please do check out the tutorial on strings on Edureka so that you will be familiar with what I'm doing here. That is the string interpolation. You'll see what it does. Now let me define one more function. Let's say define function number 2, and inside this I'm going to pass the same argument, that is name. And now I'm going to return using the string interpolation again. So after this I actually want to ask how you doing. I have to give 2 lines over here. This should do. And now I want to take one more function, guys. So I'll name it as function number 3, and inside this I'm going to pass function as an argument. So here I just want to return function number 4, and inside this, let's say I want to write dear learner. Now when I print this, I'm going to print function number 3, and inside this I'm going to pass function, that is function number 1. Now again I'm going to pass function number, let's say, 3, and inside this I'm going to pass the function number 2 again. Let's see what the output is. Okay, we have an error, guys. Function 2 is missing one required positional argument, name. So we have made a mistake over here. So when I print this now, I'm getting the output as hello dear learner and dear learner, how you doing? So I'm actually able to pass the functions as arguments. So that is actually how we use the first class object. We can use anything as an object in Python. Now moving on to the next example that I'm going to show you is for inner functions. So how exactly do you use inner functions? So I'm going to take one function, let's say func, and inside this I'm going to define one more function. So first of all, let me give it a statement. I'll say first function, and after this I'm going to define one more function, and this is going to be function number 2, or I'll just write it as function number 1. And after this I'm going to give one more statement over here, let's say first child function. Now I'm going to go define one more function, let's say function number 2, and inside this I am going to print, let's say, second child function. And let me take one more statement, so function 2 and function 1. Now when I print our function over here, let's see what the output is. So first of all, we are getting first function, that is the base function, and then we are getting the child function and the first child function. So this is how you can use inner functions in Python. Basically it's a nested function. We are using multiple functions inside a function. So we have one function over here, and inside this we have 2 more child functions. So this is a basic example of inner functions, and Python decorators is going to revolve around this concept a lot, the first class objects and inner functions. That is why I was telling you about this. I'm going to show you one more example. So I'm going to return a function from a function. So basically what it means is I am taking a function as an argument for another function. So what I'll do is I'll just write function and define one function. Over here I'll just write n, and now I'm going to define one more function, let's say function number 1. So I'm going to return, let's say edureka, yes. And now I'm going to take one more function, let's say function number 2, and inside this function I am going to return, let's say Python. And now let me take a statement, guys. So if n is equal to, let's say 1, so I'm going to return function number 1. I'll not use this, I'll tell you about this later. Else I am going to return function 2. So this is my function, guys. Inside this I have two more functions. I'll show you what it does. So I have a is equal to function, and inside this I'll write 1, and now again inside this I'll write, let's say 2. So now when I print a, and let's say I am going to print b as well, you'll see what the output is. Okay, we have name b is not defined, so actually I had to take b over here. So the output is edureka and Python. So I'm successfully able to return a function from a function, guys. So I've taken these two functions as arguments, and this is how we can return a function from a function. So now that we are through with the Python prerequisites, we'll talk about decorators in Python. A decorator is a design pattern in Python that allows a user to add new functionality to an existing object without modifying its structure. So decorators are usually called before the definition of a function you want to decorate. Let's take a simple example to understand how it works. So we'll go to PyCharm again. I'll clear this off. And okay, let me just put it right here. Now I'm going to take a simple decorator example. So I'll just define a function. Yes. And inside this, let's say I want to pass a function as an argument. I'll name it as function 1. Now again, I'm going to define a wrapper function. This is my inner function, guys, and this is basically the decorator that I'm going to use here. I'm going to pass function again, so you'll see what it does, and I'm going to print one more statement after this. So let's just say welcome to Python Edureka tutorial. Now I'm going to return wrapper over here, and I'm going to define one more function, and inside this function number 2 I am going to use a print statement, let's say Pythonista, and let's just call a function now. Function number, let's say 2 is equal to function 1 function 2. So this is a very important statement, guys. Now I'm just going to call the function number 2. Let's see what the output is. So my output is hello Pythonista, welcome to Python Edureka tutorial. So as you can see inside the wrapper function over here, first of all we are getting hello. After that, the function which we have right here, this one, function number 2, which we have passed in function number 1. So this is my wrapper statement, guys. There is another approach to this using a Py syntax, or we can call it a syntactic sugar as well. So it basically makes it easier to use decorators in Python, guys. What I'm going to do is I'm going to make a few changes in this code and you will understand what I have done. So after this statement, that is return wrapper. Okay, let me clear all this. I can just write @ function number 1, and now I'll just define my next function, that is function number 2. And over here I'll just print Pythonista, and now when I call my function number 2, the output is going to be same. So as you can see, the output is same, which is hello Pythonista, welcome to Python Edureka tutorial. So what I have changed here is I have changed this over here. So I've used this Py syntax, or you can call it a syntactic sugar as well. It makes your job easier. So this is how you can use a simple decorator in your functions, guys. So now let's try to understand the concept of decorators in Python with a few more examples. So I'm going to take a program inside which I'm going to specify a decorator with arguments. So I'll just take function number 1, and inside this I'm going to pass function again. Now I'm going to define my wrapper function inside which I will have arguments. So earlier I didn't have arguments over here, but now I'm going to have arguments inside this decorator. So I'm going to print hello again like I did in the last program, and I'm going to call the function again. So inside this I'm going to use the arguments as well, and after this I'm going to print the same statement that was welcome to Edureka Python tutorial, and I will return wrapper. After this I will use the syntactic sugar. Function number 1 I'll write, and after this I'll define my function number 2, and over here I'll write the print statement. Let's say, alright, we can use our argument over here as well, and we'll use the string interpolation again. Yeah, when I print function number 2, I'm going to specify a name as well. Let's say Wasim. Now my output is, okay, we have a error which is function 1 is not defined. So basically this, we have made a mistake over here. Now it should work fine. So we have hello Wasim, welcome to Edureka Python tutorial. So this is a very simple example, guys. So we have actually used arguments in our decorator. Let's take a look at the next function that we have. So I'm going to use a function in which I'm going to return values from a decorated function. So I'll just define a function number 1, and inside this I'll pass function again, and now I'll define a wrapper function with a few arguments, let's say, and after this it's going to work the same way like we did. So I'm going to write print, let's say it worked, so it will show us that it worked. I'll return wrapper, and after this I will have that same syntactic sugar function 1, and I'll define my function number 2 here, pass name over here, and I'll write print string interpolation get name, and now when I print, let's say function number 2 with name, let's say Python. So what is the output that we are getting? It's showing it worked. So now that we are through with the decorator examples, let's talk about fancy decorators in Python. They're nothing but the complex features of decorators in Python. And to explain this, I'm going to take a few examples like class decorator, and let's talk about them one by one. So we are making a reference here so that we can use it for various purposes in the future as well. So we are not using the parenthesis over here because we're making a reference to this function. So I'll clear this up and we'll talk about the class decorators now. So there are two ways to decorate a class in Python. The first one is where you can decorate the methods inside a class, and there are built-in decorators like class method, static method, and property in Python. So class method and static method define methods inside a class that is not connected to any other instance of a class. And property is normally used to customize the getters and setters of a class attribute. So let's take an example to understand this. So I'll take a class, I'll make it a more relatable. So I'll not use functions. Instead, I'll use, let's say, square. And for my class over here, I'm going to define few functions. So first of all, I'm going to define an init function. And inside of self, I'm using one more variable, that is side. Now self dot side is equal to side. And I'm going to add a property over here. So this is going to be my decorator, guys. So this is going to be my decorator. It's a built-in operator, guys. I'll show you what it does. So I'm going to define one more function named as, let's say, side, and inside this I'm going to pass self, and now again I'm going to return self side, and I'm going to use one more. So this is my setter function, guys, and now inside this I'm going to use the side function, and after this I'm going to use the value. So if value is greater than equal to 0, I am going to get the side is equal to value, else I'm going to print that there is one error over here. And now again I'm going to use property, and over here I'm going to define area self again, and inside this I'm going to return the area. So I'm going to use self dot side, and I'm sure everyone must be familiar with what is the area of a square, that is side square, so I'm using a double exponentiation operator over there, which is used to calculate the square. So if I make it as 3, it's going to be a cube, but we don't need that, so I'm just going to leave it at 2. Now I'm going to define a class method, and it is going to have one more function, let's say unit square, and inside this let's have one more variable cls, and now I'm going to return 1. We are done with the class, which has all these functions and built-in class decorators like property, class method, and setter and getter, all those. So I'm going to have square over here. I'm going to specify the side as 5. Now let's say what my side is. Yes, and I'm going to print the area as well. So when I do this, my output is 5 and 25. Now, sometimes it's useful to have a decorator that can keep a track of state. So let's take a few more examples to explain decorators in Python in detail. So I'm going to make a singleton class using class decorators. So first of all, I'll import func tools, and after this, I'm going to define a singleton class. So I'll name it as singleton. Now after that, I am going to use the function tools dot wraps inside this CLS. Now comes the wrapper function, and inside this I'm going to have a few arguments as well. And after this, I'm going to get the instance is equal to CLS args and chaos. I'm going to return wrapper again, making a reference to the function and not calling it, but I'm going to use this to make an wrapper dot instance. Okay, we're making a small error over here. Now I'll just write wrapper dot instance is equal to none. Now I'm going to return wrapper again. After this I have a singleton, and after this I'll have class 1. I'm going to pass, and let's say first is equal to 1, and let's say second is equal to 1 as well, and I'm going to print first is second. So let's see if we get true or false. Am I getting a error, guys? Alright, I have made a mistake over here. I had to add a if statement. That's why we're getting this error, guys. And after this, it should work fine now. So it is actually true. And we know that a singleton class only has one instance, and there are plenty of singletons in Python, including true, none, etc. So now that we are done with making a singleton class, I want to talk about nesting decorators. So in a function, you can actually use nested decorators as well. So I'll show you the syntax for that. So basically what you can do is you'll just write function 1, and you can write function 2, but you have to define all those before that you use. After that, you can just define a function name and print whatever you want. You can use multiple decorators by stacking them on top of each other. And now let's take an example in which I'm going to take arguments in a decorator. So for that, I am going to import function tools, and after this I will define a function, let's say repeat, and inside this I'll write number. Now again I'll write one more function, let's say decorator repeat, and after this I will pass a function inside this, and now I will make one decorator, let's say func tools dot wraps. Inside this I will pass function, and I'll define one more wrap function over here, and inside this I will pass a few arguments. Now for in range number value is equal to, I'm going to return value after this, and return wrapper, making not using the parenthesis again, and after this I'm going to return decorator repeat, and again not using the parenthesis. Now we make our decorator, let's say repeat. Inside this I'll specify the number itself, let's say 5. After this I'll define a function, and inside this I'll pass name. Using the string interpolation we will have a name again. So let's just say I want to print my name again, or I can use Python as well. So I'll just write Python over here. Now when I run this, there should not be any errors. So I'm getting it as Python as 4 times. So instead I can use 4 over here. I'll get it 4 times. So this is my repeat function. So I'm using it as an argument 2 times also. We can use it for 20 times as well. So it is always useful to pass an argument in a decorator.
Everything in the world of programming requires a name, but still there are a few anonymous mysteries. Lambda functions or lambda expressions are one of these kind of entities that are in fact nameless. So before we begin, just make sure guys that you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Coming back towards the session, we shall first begin with understanding what are lambda functions or lambda expressions and why they're used. Following that, I'll be showing you all how to write these lambda functions along with some user-defined functions as well as some predefined functions such as filter, map, and reduce. Finally, we'll be using these lambda functions to solve some algebraic expressions. Okay, so without any further ado, let's move on towards the first topic of this session, which is understanding what exactly are lambda functions. Python lambda functions are functions that do not have any name. They are also known as anonymous or nameless functions. The word lambda is a keyword that specifies what follows is anonymous. Now that you're aware of what these lambda functions are, let's move on further to see why they're actually used. The main purpose of anonymous functions comes into picture when you need some function just once. They are created wherever they are needed. Due to this reason, Python lambda functions are known as throwaway functions. They are also used within higher order functions which take a function as an input or return it as an output. Another very good advantage of using these lambda functions is reducing the size of code. And I'm going to be showing y'all in this session how to do this. So now let's move on towards our next topic, which is to see how to write anonymous functions. Lambda functions are created using the lambda operator, and its syntax is as follows. The first thing that you'll need to specify is the lambda keyword. And following that, you'll have to specify the arguments or the inputs. And finally, after the colon symbol, you'll have to specify the expression that needs to be solved. Lambda expressions can take any number of arguments. So as you can see over here, my first example is a lambda expression without any arguments. In the second example, I've taken a lambda expression which just has one argument a1. Finally, I'm demonstrating a lambda expression which has inputs from a1 to an. Just remember that all your arguments or inputs need to be separated by a comma. So now let's move on towards our Jupyter notebook and see how we can actually write these lambda functions. I'll just create a new notebook over here, guys. I'll just open a new notebook over here, guys, and I'll rename it as lambda functions. So guys, now just let me write the syntax as a comment over here. This is going to be good for a referral purpose. So first is the lambda keyword, like I already told y'all. Sorry guys for the spelling mistake. Lambda and the arguments followed by the expression. Okay, so the first thing I'll have to write down is the lambda keyword. Following that, I'll have to specify the arguments. So let me just give one argument to this. And after that, I'll just say I want to multiply this a with itself. So this is my lambda function. But before executing this, I'll require some variable that can hold the value of this. So I'll just specify that x is equal to this lambda function. And after this, I'll say x of 3. And I'll hit run. So as you can see over here, when I used x of 3, it's returned the output to be 9. So guys, if I had to solve the same expression using a normal function, then I would have had to write a larger piece of code than this. Let me just demonstrate this to you guys over here. So I'll just define a function. say new, and I'll pass the parameter as a. Now I'll be using return to return the value of a star a. To call this function, I'll have to use the name of the function and specify some value to the argument that I've already passed. So in place of a, I'll pass the value as 4, or let me take it as 3 itself, like the previous function, and I'll hit run. As you can see over here, using lambda functions, I just required 2 lines of code. Whereas, while using the normal function, I had to make use of 3 lines of code along with this return statement over here. Okay, so guys, I hope you all have understood how to write these lambda functions. So guys, as you all have just seen, I've used lambda expressions in the example along with some other variable x. Now I did this because these functions are nameless and require some name to be called. But doesn't it seem confusing as to why assign a name to a nameless function and what is the need of it? It's a legitimate question, guys, but the point is this is not the right way of using anonymous functions. Anonymous functions, like I've already told y'all, are best used within higher order functions. These functions either take a function as an input or return it as an output. To demonstrate this, let me just move on towards our next topic of this session. The first thing that we're going to study is anonymous functions within user-defined functions. So as you all can see on the screen, I have a user-defined function that takes the lambda function as an input. In this example over here, the normal Python function, which in my case is newfunc, takes one argument x. This argument is then added to some unknown argument which is supplied through the lambda function. Let me just jump onto my Jupyter notebook to explain this in detail. Let me just first create a heading over here, guys. Just remember the number of prefixed hashes tells which heading it is. So if it is h1, it will have 1 hash prefixed to it. If it has 2, then it's h2 and so on. So I'll just create a heading over here of h1 level and I'll give the name as user-defined functions or lambda within user-defined functions. Lambda within user-defined. So I hope you guys know what are user-defined functions. Okay, so as you all know, when you have to create a function in Python, you'll have to use the def keyword followed by the name of the function. I'll just name the function as a and I'll pass one parameter to it, say x. After that, I'll be using the return statement. And within this, I'll specify a lambda function. I'll pass y as the argument to this lambda function and I'll use x plus y as my expression. Now let me just give some value to the variable x and store it in another variable t. So a of 4 and I'll print the value of t of 8 and I'll hit run. So as you all can see on the screen, the lambda function that is used within the function a is called whenever I call this higher order function. And the first thing that I'm doing over here is passing a value to the variable x and then I'm printing the value of x plus y. So I hope everyone's understood this part. Okay, now let me just copy this function and pass a few other values to this as well. I'll just store a new value in the variable u and I'll pass the value for x as say 7 and I'll print u of 5 and I hit run. Okay, so I hope everyone's clear with this. If you have any doubts, please do let me know in the chat box and my team is here to help you. Now let's move on towards the next topic, which is using lambda functions within filter, map, and reduce functions. The filter method is used to filter the given iterables, which can either be lists, sets, etc. Now this is done with the help of another function, which is passed as an argument to test all the elements to be either true or false. After applying the function to the set of iterables, if the value is true, then that value is returned in the output. Now let me just jump onto my Jupyter notebook and use the lambda function within the filter method. I'll just give a new heading over here again. Just for your reference, guys, I'll create a heading of h2 level by prefixing it by 2 hash characters. So I'll just use lambda within filter. And since this is a method, like I already told y'all, the filter function needs iterables. Now here I'll just create a list. I'll say my list. and I'll specify some elements to this. The filter method is going to check for all the elements to either be true or false in accordance to the expression that is passed within the lambda function. Like I already told y'all, the filter method is going to check if the expression that is specified within the lambda function is either true or false for all the elements that are present within my list. And it returns all the elements that satisfies the expression. So as a result, I'll have a new list. So I'll just name it as a new list. And I'll use the filter function. And within this, I'll be using the lambda function like I already told y'all. Let me just specify the input as A. And I'll give an expression over here, say A. I just want to check if any of these values when divided by 3 will equate to 2. And I'll pass my list. And I'll pass my list as an argument to this. And since the output is going to be a list, I'll just use the list method over here. And one more point I want you guys to note is the syntax of the filter function. And since I forgot to specify this before beginning the demonstration, let me just specify the syntax of this function over here. I'll say syntax. You'll have to use the filter keyword along with some function followed by the iterables. Okay, so as you can see over here, I have the filter keyword, I have the function which is lambda, and then I've passed my list as the iterables to this function. Now let me just print the new list. And I'll hit run. Uh-oh, sorry guys, I've made a spelling mistake over here. So it's Filter. So as you can see over here, I've passed the elements 1, 2, 3, 4, 5, and 6 to this filter method. And after checking if this expression is true for all the iterables, it has returned 6 as the output. Now let me just cross-check over here. So if I divide 1 by 3, I will not get a result which is equal to 2. Similarly, if I divide 2 by 3, I'm not going to get the result as 2 again. Finally, as we all know, if I divide all these elements by 3, only for 6 I'll get the output as 2. So I hope everyone's clear with how to use the lambda function within the filter function. So now let's get back to our presentation and see how we can use the lambda function within the map function. Guys, the map function in Python is a function that applies a given function to all the iterables and returns a new list. So I hope you're understanding what exactly it does. It takes a function as the input and some iterables as well. And then it applies this function to the set of iterables that are passed and it returns a new list. So now let's get back to Jupyter and do the same. I'll create a new heading, of course. And it's going to be lambda within map. And I hit run. So before moving on towards the demonstration, I'll just write the syntax for the map function. So it has to have the map keyword, of course. And the parameters that are passed to it is a function and the iterables. Now let me just make use of the same list which I was using previously. And I'll copy that over here. And then I'll just store the output in a new list P. And I'll use the list function since I want the output to be a list. Within this, I'll use the map function. And to that map function, I'll pass a lambda function as the input. I'll just pass one argument to this as A. And the condition I'm going to specify is to check if any element present within my list divided by 3 is not equal to 2. And I'll pass my list as the set of iterables. And then finally, I'll be printing this. Now let me hit run. So as you all can see over here, it has returned a list with some Boolean values. The expression that I wanted to check is A by 3 not equal to 2. Now let me just move on to my list and see what happens when I divide 1 by 3. Of course, I'm not going to get 2, so I have true as the output. Now when I divide 2 by 3, again, I'm not going to have the output as 2, and therefore I have true as the Boolean value for this. Similarly, all the elements present in my list are divided by 3 and it's going to check if the condition is true. Therefore, only for 6 it's going to be false and I have the output as false. Okay, so I hope you guys have understood how to use the lambda function within the map function. If you have any doubts, please do let me know in the chat box, guys. and my team will revert to you. Okay, now let me just jump on towards our next topic, which is using lambda function within the reduce function. So guys, the reduce function is used to apply some other function that is passed as a parameter to it to a list of iterables, and finally it returns a single value. And to demonstrate this, I'll just jump onto my Jupyter notebook again and I'll create a heading. This is going to be lambda within reduce, and I'll hit run. So first let me just write the syntax of this function. It is the reduce keyword, and it takes a function as a parameter. The first parameter is a function, and second is a sequence. Now to make use of the reduce function, you'll have to import the functools library, or from that library, you'll have to import the reduce function. To do this, I'll be using from functools import reduce. You can also directly import the functools library as import functools, or you can also use from functools import star. These are just the alternate ways that you can also use over here. Okay, so now I'll be using the reduce function, and within this I'll specify a lambda function, and I'll pass two parameters, say a and b, and let me just print the sum of a and b. And finally it has to have a sequence as its input. So I'll just specify a list over here. I'll say the list of values to be 23, 56, 43, 98, and 1. Okay, so now let me hit run and see what it returns. So as you can see over here, guys, I have 221 as my output. So what this reduce function is actually doing is, it first adds 23 to 56. So guys, the first thing that the reduce function does is add 23 and 56. And the output of this is going to be 79. Now after adding these two values to this output, it will add 43. So to 79, it's going to add 43, and it will produce a new output. After finding the output of 79 and 48, it's going to add the result to 98. And finally, it's going to add that result with 1 and returns the final output, which is 221. So I hope you guys have understood how this function is recursively adding each value to the next value that's present in the sequence. Guys, if you have any doubts, please do let me know in the chat box. Okay, now let's move on to see how you can actually use these lambda expressions or lambda functions to solve some algebraic expressions. For this, I'll just go back to my Jupyter notebook and I'll create a heading over here. Sorry guys. I'll just delete these two kernels. And I'll create a heading. I'll just say lambda for algebra. So guys, first we'll be taking some linear equations. So I'll just create a heading as linear equations. So as we all know, algebraic linear equations consists of variables of degree 1, which means they'll have the power as 1. So now let's just use the lambda function to solve some linear equations. I'll just say S is equal to lambda, and I'll pass the argument or the input as A, and the expression I'll specify as A star A, and I'll use S of 4, and I'll hit run. So as you all can see over here, 4 cross 4 is 16. Now let me take a different linear equation. So let me just write the linear equation over here as a comment. So I just want, say, 3x plus 4y. Okay, so if I want 3x plus 4y, so I'll have to specify some name to this, say d is equal to lambda, and x and y as the inputs. And since I want 3 star x plus 4 star y. Okay, I have 3 into x plus 4 into y. Okay, And then I'll pass the values as 4, 7, and I'll hit run. As you all can see, 40 has been returned as the output when I pass the value of x as 4 and the value of y as 7. Now let me take some quadratic equation. So I hope you all know what is a quadratic equation. It's an algebraic equation with the degree 2. Let me just give the heading as quadratic equation. Okay, so now let me just try to solve the very famous a plus b the whole square. A plus b the whole square. So I'll just say part 2, okay? Now let me write a lambda function that's going to return the value of a plus b the whole square. I'll just save it within a new variable x, and I'll use the lambda function. And the arguments or the inputs are a and b. The expression that I'm going to use is a plus b. And like we all know, we'll have to use double star when we use powers. And then I'll print this x. I'll pass the values of a and b as 3, 4, and I'll hit run. Okay, so as you all can see, I found the value of a plus b the whole square using the lambda